Hey there, AP Huggernauts. This is Mr. B, and today I'm covering Learning Targets 2.1 and 2.2 from Unit 2, Population Migration, Patterns, and Processes. Today I'm going to be talking about the factors that influence the distribution of human populations at different scales, how geographers calculate population density, and how population distribution and density affect society and the environment. Now, as we move into Unit 2, I want everybody to realize that those concepts and vocabulary from Unit 1 still apply. And you're going to see them appear again and again, not only in this unit, but for all the units in the remainder of the course. So don't forget your vocab ever from this day till the end of time. Now, when I'm talking about demography, I'm talking about population studies. And a demographer is a geographer who specializes in studying human populations. So some demographers look at spatial distribution. Where do people live and what draws people to a particular place, both those physical and human factors. Okay. They may also consider why is the region's population distributed in a certain way? What about that region's population density? And of course, trying to answer the question of why should the rest of us care about this? Other demographers look at the movement of people and consider where are people migrating to and from? Why do people migrate? And how does migration affect both countries of origin and destination countries? Here's an interesting stat. 75% of the global population lives on just 5% of the land on the Earth. That suggests that there's a lot of this planet that isn't suitable for widespread human habitation. Now, if we consider that the population of the world is growing, that means in the future, there will be more and more people on less and less land. Oh boy. Okay. So I want you to ask yourself what physical factors limit and encourage where people live. I'll give you some example: climate, landforms such as mountains and deserts and bodies of water. But again, what physical factors will limit and encourage where people will live and whether or not people will inhabit a particular geographic space? And what about those human factors that limit and encourage where people live? Those cultural, economic, historical, and political factors. Start thinking about how human factors influence population distribution. So here we have a map and a question. What conclusions can you draw about how physical features influence distribution? I want you to take a moment to answer this question in your notes and hit pause. Here we have a map of population clusters where each dot, this is a dot density map, each dot represents cities with at least 1 million people as of 2006. This map is very important. You should definitely review this map throughout Unit 2. Now, the first thing about this map is that it identifies the major, largest population clusters in the world. And 3 of them are circled there for you: East Asia, South Asia, and Europe. There are 2 others that you need to know that aren't circled. There is Southeast Asia and the Northeast region of the United States. This map is also useful for just gaining insight into population distribution in various countries and regions. For example, take a look at China. You can see that the eastern half of China has a large cluster of population and is much more inhabited than the western half of the country. And most of the people in the eastern half do live along China's rivers and along the eastern coastline. Look at the continent of South America. You can see the more people live along the coast than they do on the interior of the country, especially in this area where you have that very large Amazon rainforest. Okay, here you have Australia. Most people live on the coast as opposed to the interior where you have the desert outback. Not just a place for getting a bloomin' onion, but also a very uninhabitable desert region for a lot of people. And another side thing about Australia, they tend to top the world in most like dangerous, poisonous, venomous insects and animals. So guess where I'm never going to be going in my life? The outback. Now here we have a choropleth map with a country level or national level scale of analysis that shows distribution trends. And it shows where's population growing in the world, where's population remaining stable, and where's population declining. And as I can see based on this map, that the highest rate of population growth is occurring in sub-Saharan Africa and Southwest Asia, while population decline is occurring in the Eastern European region as well as the Russia-Siberian region. Okay? The United States is experiencing population growth, but nowhere near as much as sub-Saharan Africa and Southwest Asia. Again, a map that's very useful for identifying where in the world population is growing, where's population remaining stable, where's population declining. And as you explore this unit, you're going to have to try to figure out why does that matter and why should people care if the population is growing in certain parts of the world versus declining in other parts. Okay, so I'm talking about calculating population density. Remember, density from unit one was the number of objects in a given space. So here with arithmetic density, I'm talking about the total number of people divided by the total area of a space. So total population divided by total land area. And that could be in square kilometers, or if you're one of those rebel Americans, square miles. Okay, now arithmetic density is useful. It gives me a number that can tell me if one country is more densely populated than another country. However, arithmetic density does not tell me where people are actually distributed within a country. It doesn't tell me where the people actually live. So, for example, China's arithmetic density will tell me a snapshot of China's population density, but doesn't tell me that most of the people live in the eastern half of the country. So again, arithmetic density tells me nothing about if you have an even distribution of people across the country, a cluster distribution in certain parts of the country, or a linear distribution. Okay, but again, it still has its uses as a comparison measurement. The next type of density is physiological density. Here I'm going to take the total population, but I'm going to divide by just the arable land or land that is suitable for agriculture. Okay, and if you look at the image here on the right, you see you have the same geographic space and you have the arithmetic density versus the physiological density. As you can see, those brown boxes represent land that is non-arable. So most of that geographic space is not suitable for widespread human habitation. So if I calculate the two numbers now, my arithmetic density is 2 people per square mile, while the physiological density is 20 people per square mile. That's a significant difference. So why does physiological density matter? Well, again, just like arithmetic density, it doesn't tell me where people actually live in a geographic space, but it can shed light on if a human population is exceeding the carrying capacity of a geographic space. Now, I want you to think of carrying capacity as a glass of water. Okay, the water represents the human population, the glass is a geographic space. Now, I'm going to fill up that glass with more and more people over time. Okay, but eventually, if I put too much water in a glass, it's going to spill over the rim. That means I have too many people. Now, and that glass or that geographic space can no longer support that number of people. I have now exceeded the carrying capacity of the land or the land's ability to support the population and meet the population's basic necessities of life. Okay, so that is a very useful feature of physiological density, where you can look at that number, and if you see a very, very high number compared with a very, very low arithmetic density, you can start to say to yourself, I bet that country has some issues with carrying capacity. The last density here is agricultural density, which is a total number of farmers divided by total arable land. So why the heck would I focus just on the farmers? Well, let's look at two examples here. We got Bangladesh and the Netherlands. Bangladesh is 431 farmers per square mile. The Netherlands is 31 farmers per square mile. Two different numbers. Okay, what these numbers actually can tell me is that Bangladesh is less economically developed than the Netherlands. Okay, and in general, the higher the agricultural density, the less economically developed that particular region or country or geographic space. Okay, now why is that? Well, in Bangladesh, okay, with such a high agricultural density, that probably means farmers are using simple hand tools. They don't have the money to access tractors and other farm technology. And since they're using simple farm tools, they're probably farming smaller plots of land. Well, the Netherlands having such a low agricultural density compared to Bangladesh, okay, I can infer or conclude that farmers in the Netherlands do have access to that farming technology, such as tractors, that allow fewer farmers to farm larger plots of land. Just think of the United States, for example, and how little of the population in this day and age actually farms. And that number keeps going down as farmers, fewer and fewer farmers, start farming larger and larger plots of land. So agricultural density can give you insight on a country's level of economic development. So again, what do these densities reveal? So if a country has a high physiological density, okay, and you can question, is that country's population exceeding the carrying capacity of the land? If so, where are people going to get food? Are they going to have to buy it from other regions? On the other hand, if you got a really, really low physiological density, and the geographic space could support even more people, well, what are you going to do with the excess food? Are you going to export it and sell it to other countries? Okay, and as I kind of stated earlier, if the physiological density is a lot higher than arithmetic density, you might have an issue with carrying capacity. If you really see a big gap in those numbers. For agricultural density, a high number means more people working the same land. A low number means fewer people working the same land. Focusing on carrying capacity, again, if a population reaches the carrying capacity of a geographic space and exceeds the carrying capacity capacity, we have a situation called overpopulation. And if an area is overpopulated, how are people's basic necessities in food, water, and shelter going to be met? And these are serious issues. So the last question here is, how does population distribution and density affect the society and the environment? Well, let's look at political processes. Every state in the United States is broken down into electoral districts of roughly equal population size, and they have to be equal population size based on law. Okay, now what does each electoral district do? Well, it is where people vote for a member of the House of Representatives in Congress. So every 10 years, the census collects demographic data and determines if electoral districts need to be redrawn, if the state is going to get added an added electoral district or is going to lose electoral district. Okay, and that's important because if you haven't moved but your electoral districts have changed, you can find yourself living in a different electoral district. And a general trend that happens with population distribution right now in most countries of the world, US included, is that more and more people are living in urban areas. Let's look at economic processes. A private business is going to be very interested where a population is distributed and where population is more dense. Okay, because if there's a lot of people living in a particular area, that is a larger customer base, which equals more opportunity for profit, and it equals a larger potential labor force. And obviously, towns and cities have the most concentrated populations with customers and workers. Okay, now let's look at social processes. Okay, we learned in Unit 1 that the government, U.S. government, will use census data to determine the number of social services that need to be provided to a particular geographic space. And that's be schools, police stations, fire stations, and in some cases, hospitals. I do realize that urban areas tend to have a lot more social services available than rural areas because there's more people in urban areas in need of those services. Now let's look at the environment and population distribution and density. Okay? Now, if you have a situation of overpopulation, do realize that a higher population equals more strain on a natural environment because it's more people and it's more pollution in all its forms: air, ground, water, noise, visual. Okay, that means a more rapid depletion of resources such as drinkable water. Okay? And then if you experience overpopulation, and now we're talking about, do we even have a sustainable environment? Okay, or are all the resources going to be consumed and the place becomes too polluted even for any human habitation? Okay, well, do realize favorable environmental attributes equal more people. This, people like places with a favorable climate. Okay, that places that have arable land to grow food. So I ask this question: are cities only located in places with large carrying capacity? Okay, could you think of any cities anywhere, maybe even in the United States, where it seems that that city was built specifically in a place that does not have a large carrying capacity? Okay. Again, in sum, there's a lot you need to get from this presentation. You need to understand what's meant by population distribution. Okay. You should know those major population clusters: East Asia, South Asia, Europe, Southeast Asia, and the Northeastern region of the United States. Okay, you really want to pay attention to those maps I went over in the beginning of the presentation for where population is growing, where population is declining, okay, and be able to match that to global regions. You want to know about the different types of population density, how they're calculated, what they reveal, and the limitations of each type of density. And then, of course, realize how does population distribution and density impact political processes, economic processes, social processes, and the environment. Thank you. Have a great day.